A very good morning. We are from group Lajakkuruih tablet L. I myself Prasna Sri Ravi and my other group mates are Nur Lisa Fatiha, Nur Shahira Izati and then Nur Shahira Biti Suhaidi. I'm going to present about the introduction of the Lajakkuruih tablet L. First of all, the Lajaklaku is a manufacturer that produces health supplement diet tablets called Lajakkuruih. The company produced at least 15 types of Lajakkuruih tablets with different health properties. These tablets are produced at the Lajaklaku factory and popular among the Lajaklaku consumers. In tablet manufacturing operation, there are common problems encountered, including the fluctuation in the tablet weights and then inconsistent tablet hardness, and also all these are due to the uneven powder flow into the die due to powder flow properties and uneven feeder material into the tablet press and malfunction of the pressing machine. So, we are assigned to monitor each tablet according to the group. So, we are assigned to monitor the tablet Lajakkuruih L. According to the data given on weight of the Lajakkuruih tablet L, we come up with a frequency table, graph and chart. As you can see that according to the weight, which is less than 320, the frequency are 2, while for the others are stated over there. We use a pivot table method to produce the frequency table. Next, the histogram for the weight for pill Lajakkuruih L can be seen over there. As you can see, the weight are fluctuating. And next is the frequency chart for the weight for pill Lajakkuruih L.
Now we look at question B. According to the Food and Drugs Administration (FDA), the standard weight of the tablet must follow the normal distribution with mean 350 mg and standard deviation 14 mg. Therefore, the following hypothesis is obtained. The null hypothesis is weight of standard tablet does follow normal distribution with mean 350 mg and standard deviation 14 mg, while the alternative hypothesis is the weight of the standard tablet does not follow normal distribution with mean 350 mg and standard deviation 14 mg. The test statistic is find out by producing this table. So the first column, OI, is obtained from the frequency table and the summation of OI is equal to 200. And the second column is the probability is obtained by standardizing the values from the frequency table and the summation of the probability is equal to 1. And the third column is EI. EI is obtained by multiplying the number of samples with the probability. Before we proceed to the next step, we need to make sure that EI is larger than 5. If EI is smaller than 5, we need to merge. So look at the first row, we obtain the EI is 3.24. Therefore, we need to merge the first row with the second row. And look at the last row, we obtain the EI is equal to 3.24. Therefore, we need to merge with the seventh row. Then we can proceed to the next step. The next step is producing the fourth column, which is OI minus with EI to the power of 2 and divided by EI. Hence, the summation of the last column, you will obtain the chi-square test, which is 9.4197. Since the EI is larger than 5, K is equal to 6 and P equal to 0. And the decision rule we can obtain by finding the degrees of freedom, which is B equal to K minus P minus 1. Which from this test, we have the degrees of freedom is 5. And the chi-squared alpha Alpha here we use 0.05. Therefore, the chi-squared alpha V we have is 11.0705. The graph below shows the rejection region of the 11.0705. Therefore, we reject null hypothesis if the chi-squared test is larger than chi-squared alpha V. For the conclusion, the chi-squared test we obtained just now is 9.4197, which is less than chi-squared alpha V equal to which is equal to 11.0705. Therefore, we fail to reject the null hypothesis. Hence, we can conclude that the weight of the standard tablet does follow the normal distribution with the mean of 250 milligrams and standard deviation 14 milligrams at alpha equal to 0.05. Therefore, there is no significant difference between the tablet weights from the different shapes.
My name is Shaira Isati binti Abu Hassan. I would like to present the question D, which is we need to find the prediction of the tensile strength for 68%, 74.3, and 80.1% based on the relative density. So for this question, we use a linear regression model. Linear regression model is linear approach to modeling the relationship between a dependent and independent variable. From the data, tensile strength is dependent variable and relative density is independent variable. So the linearity test is made to conduct to test if the relationship between tensile strength and the relative density is linear or non-linear. So the linearity test result conclude that 95% confident interval in linear relationship between tensile strength of tablet and relative density is valid. So the equation for the relationship is y equal to mx plus c. Y is tensile strength, m is gradient, x is relative density of the field, c is the intercept. The gradient and intercept we get from the linear fit plot from the Excel analysis. So this is the Excel analysis. From the Excel we get intercept and relative density and some value, which is coefficient, standard error, t-stat, p-value, lower and upper 95%, lower and upper 95.0%. So we get the equation y equal to 0.0831x minus 0.2289. The next slide will be presented by my group member, Musyairah binti Shuhaidi. Thank you.
For prediction of tensile strength for 68%, 74.3%, and 80.1%, we're going to calculate the predicted tensile strength from the previous equation, which is y equal to 0.0831x minus 0.2289. For relative density 68%, we get the predicted tensile strength is 5.4219 MPa. For 74.3%, we get the predicted tensile strength, which is 5.9453 MPa. While for the 80.1%, we get the predicted tensile strength is 6.4274 MPa. For estimation error, for 68% relative density, we get the predicted tensile strength range is from 5.4219 till 5.6505 MPa. For 74.3% relative density, we get the predicted tensile strength range from 5.9453 till 6.1743 MPa. Lastly, we get the relative density 80.1%. We managed to get the predicted tensile strength is 9. Okay. For relative density 80.1%, we get the predicted tensile strength range from 6.4274 till 6.6563. For lower limit tensile strength prediction, their intercept is 0. So we're gonna use the equation y equal to 0.0831 times 68 plus 0 because the intercept is 0. So we managed to get the y equal to 5.6505 MPa for the lower limit tensile strength prediction. Next, as a linear regression model is valid to predict the test result of the tensile strength of the tablet based on its relative density with up to 95% accuracy. As a conclusion, chi-square test used with the probability of normal distribution. For this project, we are using the goodness of fit test. The weight of standard tablet does follow normal distribution with mean 350 and standard deviation 14 at alpha 0.05. While for the linear regression model used to predict the test result of the tensile strength of the tablet, 95% confidence interval in linear relationship between tensile strength of tablet and the relative density is valid.